So the topic today is RISE for education, um, and we believe, and there are several reasons why RISE is a perfect fit for EDU and education at both high schools, technical colleges, as well as universities. So before we get into all the details, I want to give you a quick introduction of RISE and its portfolio and what we are trying to do, and go from there. So RIZE is a startup out of Boston, founded in 2014, and we have been shipping printers commercially for a year or so. Um, so what our goal and our mission and what we have delivered to the market is desktop industrial 3D printing. Our customers, we have more than triple digit customers now using our products, companies like Google, ABB, Festo, Ford, and many others using RISE 3D printers. But the key value proposition of RISE is it is simple. A student, whether someone is in a high school or a university, can actually do industrial 3D printing with a few clicks once the design is done, and have a very high quality part come out of this printer. And this printer is designed to run 24/7. It's safe. There are many material innovations that we have done on RISE, where you get zero emissions. Actually, it's people safe, it's environment safe, it protects your IP, and it's digitally traceable. So what we mean by safety here is RISE actually connects your digital to the physical and back to the digital, and we will talk a little bit more about it. The speed. One of the things we focused on when we founded the company is to basically create a printer where there is minimal pre-processing, which means the number of clicks you have to do before the printer will start to print, and the effort that you need to do once the part is built inside the 3D printer, removing the supports and such, and we will talk a bit more about it, as well as strength. The RISE parts that come out of this printer has pretty close strength in the Z as in X and Y. And even though it's we print layer by layer, many of the innovations allow to give you best in class Z strength. And what does it mean to a school or a university? You could have a new batch of students in a given semester start to use RISE effectively in less than 20 minutes, like many of our customers, and do very high quality, reliable 3D printing. And what it also means to schools is this is a printer that runs 24/7 and ready to go. So we have two products right now. One is RISE 1, which is what we call monochrome, into the marketplace. And we recently announced another product, XRIZE, at Formnext last year. And this is what we call an all-in-one printer. It does our Rizium products, carbon and in full color, all-in-one printer. And we will talk a bit more about it. And there are many applications for color inside schools and universities. In terms of materials, and I think you might be a bit surprised to see inks here. So this printer is what we call a augmented deposition printer. You can actually combine inks and release inks and materials all together, the job done. So basically what we have with RISE right now is Rizium 1, which is a proprietary material, and I will talk a bit more about it, as well as in both white and black, carbon, that we'll be releasing end of this month, early next month. And we also have something called Release 1 ink. And what this Release ink does, it actually allows you to peel away the supports, and the marking ink allows you to do full traceability. So these are the different kinds of materials that are used inside RISE. And obviously you can see here, you can do, once you do a finite element analysis or a CFD analysis, you can actually print it and actually use it as part of the school projects, or any number of things that you can do inside the product. So the software, and this is another key innovation, just like we have innovated on desktop industrial 3D printing on the hardware, just like we have innovations on the material, and now we have innovations on the software. It's unique and purpose-built. It does actually voxel level 3D printing, where it does automatic support generation and support removal with releasings. It applies very intelligently the releasings and markings, as well as option for solid and partial fill. There's a built-in slicer, and it's very easy to use. So literally, we have users and customers that actually once they have a 3D model done in SolidWorks or any other products, with 3 or 4 clicks they are ready to print. And by the way, prior to joining RIZE, I joined RIZE last year in early June. Before that, I was VP of Product Management at SolidWorks, been with SolidWorks for 20 plus years. And so one of the reasons I joined RIZE is the same value proposition on 3D printing that SolidWorks offers on design applications similar to Inventor and many others. So we have innovations on software, innovations on hardware, innovations on materials, and I will talk a bit more about that, and also how we address some of the challenges inside universities. RISE truly is an appliance. It's almost like it works like, in terms of a user experience. Once you have the digital model that you see in the bottom, going from the digital model to creating the part and time to part, it's incredibly seamless. No barriers at all. And our customers tell us that compared to many other industrial 3D printers in the market, they are able to print 50% plus faster and 1/3 of the cost versus other 3D printers that they use. One of the key innovations we have is what we call augmented polymer deposition. The way it works, it's actually we combined both the material extrusion as well as material jetting, which is special inks that you can use to do many things inside the product. One is you can put a support layer like you see, and in between the support layer and the part, you can use with material jetting, we put release inks. So the supports come off cleanly, your geometry is precise once you remove the supports. So we have very high geometric integrity after the supports are removed. And the users, in fact, our customers, do not do any post-process finish to get the right surface finish once the supports come out. Not only that, with material jetting, we jet at the voxel level inside the part. So now, you can see all these different shapes. You can see penetrations between the part. So now we have a printer that's industrial, desktop, incredibly easy to use with full voxel level control and such. We have certain customers under research with us trying to print copper inside the plastic parts, biologics, and many other things. And so what this technology allows you to do inside universities is do research on some very interesting areas, as well as make it incredibly easy for users, students, professors, and teachers to get their job done. So here's one example. On the left-hand side is RIZE, and you can see how the supports are coming off. And on the right-hand side is traditional 3D printing. So you can see that to remove supports, it's just you just use your hands to remove them because of how we put the release ink in between the part and the support. And you can use simple pliers like that to remove internal supports, and literally in less than a minute, you have a part in hand once the part comes out of the 3D printer. And in some FDM, it can take up to 3 hours. And because of the releasing, the surface finish is perfect once you remove the supports that come out of the part. Now, another innovation is material. We actually looked for clean materials in many industries, and we use what we call cycloolefin polymer that you see on the right here in this material table. Internally, we call it as Rhizome 1, but COP or cycloolefin polymer is a very high-end engineering polymer. It's used extensively in medical as well as semiconductor industry for its clean properties. And so we extrude this material at 275 degrees Celsius, and at that time it has zero outgassing, and it has zero any kind of emissions that actually come out of this material. In fact, there is no mass change as you actually print this particular material on this on RIZE 1. and and it actually mimics injection molded strength, because the XZ strength is the same as the other two directions as well. So it has very high Z strength, very close to X and Y. It's people safe. The ingredients of COP are USP Class 6 certified. Um, Even though we haven't certified Rhizium 1 ourselves, but pretty much Rhizium 1 is made of COP, and we have companies like Merck, ConMed, and other medical companies using Rhizium for its chemical resistance. It's resistant to acids, it's resistant to many things, and as well as strong. And as you can see in this particular chart, it's twice as strong as ABS, stronger than polypropylene, and stronger than polycarbonate, stronger than acrylic, and it's on the amorphous side of things. The other thing about this made up of cycloolefin polymer is it's fully recyclable. Once the part is built and the supports are removed, you can just throw supports into the recycle bin. There is no toxic or hazardous material that comes out of the RIZE printer, and that's the reason why it's in a submarine and such. It has minimal shrinkage. It is UV stable. We have many companies that have tested this plastic part for UV stability. It has high moisture barrier, and in fact, compared to it has negligible moisture absorption intake, less than 0.01%, versus 1% for ABS, and even higher for nylon and many other materials. It also has very unique mechanical, thermal, and electrical properties, this particular material. High dimensional stability and good insulator because of very low thermal expansion coefficient, as well as moisture absorption. So you can actually print parts using COP and Rhizium 1, and after 6 months or a year of actually doing this, your dimensional stability is intact. It has very low surface energy and non-reactive surfaces. And this is the reason why many of our customers have actually created molds, and without using any mold release agent, they are able to pour certain materials that actually solidify, creating gaskets and things like that, and they just remove it without any mold release agent out of COP based molds. It has very good volume resistivity, unique the electrical properties that resist dielectric breakdown. You can see the strength, dielectric breakdown strength right there, and the dielectric constant. It has very high strength to weight ratio, and in fact, it's very close to water in terms of specific gravity. It's 1.01. So there are very unique reasons, and the material is an innovation. The way we compound it, the way we extrude it, and the way we 3D print the part, and the way the material flows when you are actually printing the part gives you some fantastic Z strength as well. The printer itself has many characteristics like hot swap. So you have two spools. If one spool is over during the print, the second spool will automatically take over. It is a heated chamber. In other words, you are printing at a constant 53 degrees Celsius inside. The doors lock. So there are many innovations in this printer. I'm not going to go into all those details, but basically what you have is the industrial desktop 3D printing with some fantastic material innovations that give you the right strength. The way this printer works is, if you have SolidWorks, and probably many of you do, or Creo or Inventor, from inside SolidWorks, you do a very simple click. And once you do that, the part opens inside the RIZE, what we call One Touch, which is a pre-processing software. And once it comes into RIZE One Touch, what happens is you can quickly orient it in any direction that you like. You can center it, but you can add text to it. So the way you do that is, you can actually now imagine this is a student ID, and a student can actually put their ID, locate it anywhere. It actually conforms to the geometry, and there it is. You can also put QR codes, for example. If you have a project report, what you can do is, on this particular part, you can generate a QR code that connects to the project report on Google Docs or wherever that is. And once you're done, you can tell who made this, when was it made, who is the student, student name, project, assignment numbers, and all that stuff. So even for the professor, they can scan the QR code and very quickly they know exactly who did it. So you have traceability, your authenticity, and all that good stuff. And once you're done, you do one click, automatically it creates all the supports that is necessary, and you're ready to print. So there is a RIZE 3D printer. So it's automatically leveled when it comes from the factory. You never ever level this particular printer. Those are all the materials. You can see the two spools of filaments, release inks, and marking inks. You select the part, and at this point, you hit print. If there aren't enough supplies, it doesn't allow you to print. The door is automatically locked during the print process. We have some patented technologies on auto leveling and things like that. We do a 6-point check, and after that, it's ready to go. And you can see on the top the print head, where it's fairly it has both the extrusion as well as inkjetting built in. And as the part is being printed, you can see the inks that actually show the logo of RIZE right there. As well as once the part is done, there's a QR code and the rest to go. While you are slicing, you have full control on whether you want 100% solid part or you want a partial fill, and you can actually tell the percentage of partial fill that you can do to get the job done. And there's a part with all the supports and the rest. To remove the build plates magnetic, so you just slide it out. And removing supports is what you see here. And you can see the surface finish once the supports come out, because there's a release ink that allows easy peel away supports that comes out of the part. A couple of more clicks, and in less than 20 you have a part in hand. And I talked to you about the QR code. So now what you do is you do a QR code, check it right there, and it gives you all the metadata that goes with that particular part to get the job done. And the same thing happens with color as well, full color 3D printing. So one of the things we do, and in fact, a lot of our large customers absolutely love this, is IP protection and what we call digital augmentation. So now you have a digital part where you have IP protected in PLM, ERP, PDM, and many systems. And once you 3D print it with code, you're all set. And you just saw how the print process works, so I'm not going to repeat. But then here is a generative design shape that was done in CATIA. And once it's 3D printed, you can actually have all the connections back to the digital information, the name of the part, the version codes, and everything else. Okay. You can go to our website, rize3d.com, and you can see the part gallery. Here are some of the examples of the color 3D printers, the topographical maps. Here is an FEA. Here is for, if you have architecture or consumer product students in the university, they can actually create exact replicas of the final product in full color and use it for testing feedback and such. And here's an example of a full carbon part. Here's another example of a carbon part. And you can see the post-processing time, 3 minutes for this, less than a minute for this connecting rod, less than a minute for this topographical map, and the same goes for the rest as well. So when we talk about 3D for education, basically what happens is a lot of students deal with this. They have pre-processing software that's tedious, complex. And we remove all those complexity from the RIZE software when you use it for with students, whether they are in their high schools, secondary schools, colleges, first year, second year, master's, research, it doesn't matter. The post-processing, we just saw it, is slow, costly, messy, and safe. You don't have to worry about any of those with RIZE. First of all, there are no emissions, nothing, and the material is proven to be skin safe, at least the core ingredients, and so there are no liability issues of any kind for universities. We have a perfect combination of material strength, properties, we talked about that. Likewise, you know, when you add this to your lab, you're expanding all the different, removing the bottlenecks and such for students, and your full marking and color capabilities that come with the printer, with safe materials and processes as parts are printed inside RIZE. And it's affordable. You must have seen in right around Formnext time, Georgia Institute of Technology did a 2-year study on similar technologies of 3D printers, and this extends to powder. Powder is very unsafe and messy with when you print, as well as post-process things. And what they have found is there are 200 plus volatile organic compounds, irritants, and carcinogens that come out of each printer when the 3D printing is happening. And you have some very toxic stuff like formaldehydes, styrenes, caprolactam, and more that actually come out when doing the 3D printing process. We are incredibly proud on how the values on which RIZE was built. The material, cycloaluminum polymer at the temperature where we actually extrude, there are enough data to prove that there are zero emissions and zero mass loss that comes out of this material in terms of usage, long-term usage of this particular material and the printer. And also your full traceability, authentication, and color. The world around us is in color. 3D printing need to be the same. It has to replicate real life, whether you're doing design, whether you're are in different colors. You can highlight certain dimensions that are critical to manufacturing. You can highlight certain surfaces and include text that talk about surface finish. You can tell critical dimensions for inspection. You can use color for design to manufacturing handoff. You can actually use color for architecture and AEC students. You can use color for finite element analysis, CFD, and such. So the applications are numerous. And this is a all-in-one printer that allows you to print in Rhizome, allows you to print in chopped carbon for strength and toughness, allows you to print in full color as well. And the students can actually put their unique IDs, student IDs for identification purposes, as well as version numbers. A lot of times innovation happens and you have multiple versions of the same innovation or same design. Whether you're doing robotics, whether you're doing Formula One, doesn't matter. And you can actually put version numbers and QR codes that actually tell when was this built, who built it, which version it is. And sometimes the dimensional changes are so small, it's very hard to tell the difference between one version versus another. And this allows you to for that digital traceability and authentic parts. And so this is a full color 3D printer. It's a breakthrough. We talked about the way this process works. It's safe, people safe and secure, zero VOCs, medical grade ingredients, skin and food contact safe. It's recyclable print material, and we're incredibly proud that that in 2018, end of 2018, we got an award from Frost and Sullivan for best practices in technology innovation in zero emission polymer material additive manufacturing industry. And you can read more about it by going to rize3d.com. Okay, as we get closer, it's very easy to use one-click pre-processing, post-processing, and we have many students actually that are 3D printed parts, like you see here. They actually tell the part, what is the context of it, the number, the team number, the QR codes, and all that good stuff. And you can see some of the color parts print. This is for a medical application, the brain stem that's showing some cancerous tissue growth, some arts, product design, engineering, geography, architecture, and geology kind of things, and with 810,000 unique colors that come out of RIZE. And here's an example of the first robotics team. They designed an integrated pulley sprocket for first power-up competition. They say isotropic, but I wouldn't say isotropic. It's more best-in-class Z strength. There's a small difference in strength in Z compared to X and Y. And it's printed in one piece, obviously, operated with cable chains, turn sprockets into the drum of the pulley. And they selected RIZE because it's twice as strong as ABS, stronger than polycarbonate and polypropylene. And here's where it went on that particular robot. Labeling, you saw that. The robot actually collected 4-pound boxes, moved across the gymnasium, lifted to full extension in 3 seconds. It stacked the boxes, obviously, and you can see the part was used at 40 matches and practices. Obviously, it survived all that at safe, clean material process for students. So, thank you very much for attending this session today. If you are running an additive lab at your university or high school or technical college, wherever you are, or you are a department looking for a RISE printer or looking for research, this is perfect for you. This purpose-built industrial desktop 3D printing, very high quality, repeatable, accurate, high dimensionally accurate parts. You can always go and read more about RISE. It's at rise3d.com. And you can always send us an email to learn more. Hopefully, we hope that you actually use RISE at your facility and university. I will stay on for a few more minutes if you have any questions. Otherwise, feel free to let us know, contact us, and we go from there. Thanks for your time.